This is the title of the quiz question. It sets the stage for a problem involving the LeavePOut cross-validation technique in scikit-learn, a popular machine learning library. This is the title of the quiz question. It sets the stage for a problem involving the LeavePOut cross-validation technique in scikit-learn, a popular machine learning library. The problem statement begins here. We're using a specific cross-validation method, LeavePOut, which is part of the scikit-learn library. The goal is to evaluate a machine learning model. We have 10 samples in our dataset, and want each sample to be left out exactly twice during cross-validation. This is key to the problem. The problem statement begins here. We're using a specific cross-validation method, LeavePOut, which is part of the scikit-learn library. The goal is to evaluate a machine learning model. We have 10 samples in our dataset, and want each sample to be left out exactly twice during cross-validation. This is key to the problem. This is the first option. Means we have 10 total samples, n equals 10, and leave out 2 samples in each iteration. P equals 2. We need to determine if this configuration meets the requirement of each sample being left out exactly twice. This is the first option. Means we have 10 total samples, n equals 10, and leave out 2 samples in each iteration. P equals 2. We need to determine if this configuration meets the requirement of each sample being left out exactly twice. Similar to option A, this option uses. Here, 10 samples are used and 8 samples are left out in each iteration. We need to evaluate whether it satisfies the condition that each sample is left out exactly twice. Similar to option A, this option uses. Here, 10 samples are used and 8 samples are left out in each iteration. We need to evaluate whether it satisfies the condition that each sample is left out exactly twice. Here, option C presents, using 10 samples and leaving out 5 in each iteration. Again, we analyze whether the condition holds. Is each sample left out exactly twice? Here, option C presents, using 10 samples and leaving out 5 in each iteration. Again, we analyze whether the condition holds. Is each sample left out exactly twice? The last option is, which involves 10 samples with 1 sample left out each time. We have to check if this satisfies the twice left out requirement. The last option is, which involves 10 samples with 1 sample left out each time. We have to check if this satisfies the twice left out requirement. This likely indicates the section where the answer choices for the quiz are presented. It's a visual cue. This likely indicates the section where the answer choices for the quiz are presented. It's a visual cue. This line sets the stage for the quiz. The core challenge is to find a way to evaluate a machine learning model using a specific cross-validation technique, LeavePOut, where each data point is left out for testing precisely 2 times. It's a bit like making sure everyone gets a fair chance to be tested. It introduces the key concept of ensuring every sample is left out twice during model evaluation. This specifies the size of the dataset. Having 10 samples is important information because it limits the possible configurations of LeavePOut and helps to understand how the combinations work. This clarifies the objective, to determine which LeavePOut configuration ensures each of the 10 samples is excluded from the training data exactly 2 times during the cross-validation process. It highlights the core requirement, which involves the LeavePOut parameters and the resulting number of times each sample is left out for testing. The goal is to find a configuration where each of the 10 samples is omitted precisely 2 times during the cross-validation process. This ensures a balanced evaluation of the model's performance. Think of it like making sure every student gets exactly 2 turns to answer a question in a classroom test. Here, we're using scikit-learn's LeavePOut function. N represents the total number of samples, 10 in this case, and P is the number of samples to leave out for each test set. We need to figure out what value of P makes sure every sample is left out exactly twice. This option suggests leaving out 5 samples for each test. Let's explore if this satisfies the goal. If you leave out 5, you're using the remaining 5 for training. Does every sample get left out exactly twice with this setup? Let's check. This implies that only one sample is omitted at each iteration. While simple, will each of the 10 samples get to be left out exactly twice? Let's investigate. This option involves leaving out 8 samples per test. Intriguingly, this is mathematically equivalent to leaving out only 2. Is this the solution? Let's examine it more deeply. We're working with a dataset containing 10 samples or data points. This is the total number of items being processed by the "LeavePOut" function. This number is crucial in determining how many possible combinations and hence tests we can perform. The overall problem involves evaluating a machine learning model using a technique called LeavePOut cross-validation. We're using a specific method, "LeavePOut", to test the model's effectiveness. A key aspect is ensuring fair representation of each data point. This is the core question of the quiz. Based on our analysis of how "LeavePOut" works with the provided options, A, B, C, D, which configuration of the "LeavePOut" function, with differing values of P, ensures that every sample is left out precisely twice for model evaluation? Think about it. The problem presents a scenario involving scikit-learn's cross-validation. Is a technique used to evaluate machine learning models by systematically leaving out portions of the data for testing. The core challenge is to determine which settings of the function will ensure each data point is excluded exactly twice during the model's evaluation. This requires a good understanding of the function's behavior and its parameters. The problem focuses on the interplay between the number of total samples, n, and the number of samples to leave out in each iteration, p. It's a bit of a combinatorics puzzle disguised as a machine learning question. The dataset for this problem consists of 10 samples. This is a key parameter in the function. Understanding this fact is crucial in determining how the function will split the data into training and testing sets and how frequently each sample will be left out for testing. Think of these 10 samples as your experimental units. Perhaps you're studying 10 different types of plants and measuring their growth, and the model aims to predict growth based on other characteristics. In this case, the question involves figuring out how to ensure each plant is left out twice in the model's evaluation. This option specifies a cross-validation configuration where the total number of samples, n, is 10, and the number of samples left out in each iteration, p, is 2. This means that in each iteration, the model will be trained on 8 samples and tested on 2. The question asks whether this will result in each sample being left out exactly twice. We'll need to do some calculations, or perhaps some clever reasoning, to see if that's true. This option is similar to option A here. N is still 10, but P is now 8. This looks different, but mathematically, it is equivalent to leaving out 2 samples. Similar to option A, it's like looking at the same coin from 2 different sides. The group left out is 8 samples, but it implies that 2 samples are used for training. In this case, N is 10, and P is 5. This means that in each iteration, half of the samples, 5, are left out for testing, and the other half is used for training. The question is whether this setting will leave out each sample exactly twice. This is another possible configuration that will need to be investigated. This option sets N to 10 and P to 1. This is yet another choice of parameter values for the LeavePOut function. Each time only one sample is left out. We need to figure out whether this will lead to each sample being left out exactly twice. This refers to a method in scikit-learn, a popular Python library for machine learning. It's a way to test how well a machine learning model generalizes to unseen data. The idea is to repeatedly split your data into training and testing sets, training the model on one set and evaluating it on the other. LeavePOut is a specific type of cross-validation where a fixed number of samples are always left out for testing. Let's see how this works in practice. We have a small dataset containing only 10 data points. This makes the analysis a bit easier to follow. This is our total data which we'll divide to train and test our machine learning model. Our main objective is to configure the LeavePOut cross-validation such that every single one of the 10 data points is used as part of the test set precisely 2 times. This is crucial for ensuring a fair and robust evaluation of our model. We're seeking a balanced evaluation of our model's performance. Here, "N" represents the total number of samples, 10, and "P" represents the number of samples to leave out in each test set, 2. This means we're creating test sets of size 2. Will this configuration satisfy the requirement that each sample is left out exactly twice? Let's explore this using combinations calculations. In this case, we're leaving out 8 samples, P equals 8 from the 10 total samples, N equals 10 . This essentially means that only 2 samples are included in the training set at any given time. Is this the same as leaving out 2 samples, and if so, why is it? With P equals 5 we are leaving out 5 samples for each test. This makes our training and testing sets of equal size. But, will this lead to each sample being left out exactly twice? Let's check by calculating the combinations. Leaving out only one sample, P equals 1 at a time. This would lead to a very large number of iterations and a much larger chance that each sample is left out multiple times. However, would it satisfy the condition of each sample being left out exactly twice? This needs calculation.